Yeah, we can see your screen, please.
Okay, I'm Alena, and let me present a current topic, extended IMECA technique for assessing risk of successful cyber attacks. So we'll start from risk assessment definition, who use it and why. Next will be a short overview of existing risk-based methodologies, challenges, and objectives. Remind default IMECA analysis and overview some components of a new extended version. After, IMECA will be combined with questionnaire methodology and demonstrated example of usage. Finalizes the report with conclusions. So, according to IBM's cost of data breach report for this year, risk assessment remains one of the most used methods. For example, was record that 36% of organization relied only on CSV assessment, while other 64% use risk-based analysis. There was a big difference, approximately 18% in cost of data breaches, depending on chosen method. What actually confirms relevance of this research? In general, risk assessment is a process of identifying, analyzing, and evaluating risk and hazards. So the whole point of risk assessment is to reduce the risk. There are many risk-based methods such as Octavia and NIST. It provides a general approach how to identify and analyze the risk. The main challenges its formalization and incomplete computer-aided support and influence of expert assessment. The objective of this study is suggest extended ontology-oriented model of IMECA and develop questionnaire-based technique to minimize influence of expert errors. Standard IMECA stands for Intrusion Modes Effects Criticality Analysis. It contains threats, what used to attack the system, vulnerability, weak part of the system, actual attack, exploitation vulnerability, consequences, criticality that includes probability, risk, and severity, and countermeasurements. In advanced version was added recovery time to evaluate criticality and new property, impact of other attack and on other attack. Other parameters were detailed. Let's go through each one by one. Threat is proposed to classify it into traditional, initiated by human, and AI-powered threats. That involves AI technology to automate the attack, e.g., captcha solving or malicious chatbots, and it could be partially AI automated, for example, AI phishing link generation with traditional dissemination. Next parameter is vulnerability. Invulnerability is necessary to determine the root causes. It could be problem with code, configuration, designs, or vulnerability of used technology. Also, it's important to get information about prevalence of certain vulnerabilities and attacks. This data could be found in global reports or resources such as NVD, WASP, or CVSS. Besides, in process of vulnerability analysis, is need to understand the attack phase, dynamic or static, in order to take correct actions for prevention. In order to define more accurate components of attack, better to know who and with what purpose is about to attack your system. It could be activists, competitors, third-party services, service provider, and so on. Attackers may have specific goals or do it without any intention. Understanding attacking possibilities also will help predict the attack. Next is attacks consequences. Attack effects is split by technical and business. Technical consequences determine how much data or hardware, software are affected. Business consequences are mostly determined by organizational losses. The newly added parameter impact of other attack or on other attack. Some successful attack could expose new vulnerabilities or mask other attacks. In this case, attack split it into single or isolated attack, what doesn't depend on other parallel or previous attack, and interconnected attack that could depend on other attack or increase the risk of other attack exploitation. Next, go for criticality and risk calculation. Risk calculation is one of important part of evaluation. For risk calculation, besides severity probability, was decided to add recovery time. The less recovery time it takes, it creates the greatest resistance. And as mentioned before, need to take into account previous or parallel attack. As a result, two-dimensional risk matrix that has original IMECA analysis becomes three-dimensional and determines for both types of attacks, isolated and interconnected. After risk prioritizing, it's crucial to choose correct countermeasurements. Questionnaire methodology is targeted to make this process more clear. Cybersecurity experts should determine a set of questions regarding the attack and countermeasurements, metrics, and properties with predefined range answers. For each answers, need to set value from defined range and coefficient for each questions. On this basis, score will be calculated. Let's see example of usage. It will be a DDoS attack in the financial sector. This for demonstrational only. Assume that it's a traditional threat without any AI usages. The most possible threat actors are competitors that have all capabilities and highly motivated. According to report data, financial sector is the most attacked, mostly of configuration flaws or absence of countermeasurements. Technical effects are loss of availability, business effects are loss of profit. About the impact. Let's imagine that we have anomaly detector that determines DDoS and intrusion attack. In this case of simultaneous attack, it's significant to check if system is able to recognize both of them. Next, based on all previous known, and recovery time approximately 4 hours. So summarize that the risk is pretty high. Next step, it's countermeasurement evaluation. The most important part is to choose relevant metrics and questions and set coefficient for these questions. Set value for each answers. And in this case, we're choosing parameters such as traffic size, speed of detection, difficulty of use, cost, flexibility, scalability, and intelligence. For evaluating the effectiveness, using formula from the screen, we get effectiveness for example, countermeasurements approximately 68%. Same process could be done for another countermeasurements, and in the end, need to compare the result and choose a more appropriate solution. Finally, the main contribution of this study, it's improve IMECA analysis, adding dependence attack from each other and recovery time, and its combination with questionnaire technique. It should help to avoid subjective factors such as expert opinion and increase the validity and accuracy of assessing the criticality of threats and comparing various countermeasurements. Future research may be devoted to development of methodologies for analyzing operational cycles of cyber attacks carried out with the help of AI. This is the end. Thank you for your attention.
Okay, thanks, Elena, for your presentation. We have now time for question. Colleagues, please welcome for your question to Elena. Yes, Vyacheslav, please ask a question.
Maybe it's a strange situation when I as a co-author will ask Elena, but we discussed yesterday aspect of application of IMECA analysis as non-completely formal methods with more formal methods, for example, which was presented by Professor Lidichevsky based on algebraic symbolic methods. And I suggest discuss, is it possible to combine IMECA analysis with more formal techniques? What is your opinion, Elena, concerning possibility of combined application of such formal methods based on the strong mathematics and semi-formal methods similar IMECA? Thank you.
Yes, thank you for question. I think it's in general possible. As it was said yesterday, the main problem of symbolic or algebraic approach is creation of these algebraic patterns that based on some attack behaviors and actions. So for this, we need to know attacks and their phases and relations. This relation could be defined via extended IMECA analysis. So we will have a chain of attacks, and it will help to define probable patterns.
Thank you.
Okay, Yuri Kondratenko, please, your question.
Can you show the slide where you told about results 68%?
This one?
Yeah, this one. Yeah, this one. So how did you calculate this value? Take it into account this seven. This is like criteria or component. You use here the weight coefficients. How it was calculated, and where did you take these parameters?
Okay, so for evaluating countermeasurements, in formula we have for each limited set of questions. It's n. For each question, we assign coefficient from 0. That in some coefficients should be 1. So from 0 to 1. For each answer, we should choose a value. We can arrange answer from the worst to the best. We should choose a value and using a formula on the screen that were presented in attached article. It will be calculated countermeasurements between 0 and 100.
Okay, but how you got this parameter? For example, traffic size coefficient 0.2 or
It should
scalability
be
0.3. Is it expert?
yes, it should be
Expert
chosen by
level.
cybersecurity expert.
Okay. Okay. Thank you very much. Thank you.
Okay, Alexander Stuk, please, your question.
Yes, just a small question. How do you think are these large language models like ChatGPT a threat in terms of cybersecurity? And if they are, what should be taken in this regard to mitigate the possible potential risks?
I think, thank you for your question. I think it could be a threat from point of view that a lot of people use ChatGPT in their for commercial purposes, let's say, and the main problem it's confidential data leak that users put to ChatGPT. So maybe I think this is the main problem.
Thank you.
Colleagues, do you have any other comments, question to Elena? If not, Elena, I have a couple of very simple questions for you. Talking about criticality, did you take into account while considering this detectability of the possible threats or attack?
Detectability. What do you mean?
Detectability.
I have detectability in vulnerability description. It's static and dynamic. So it's not directly impact on risk, but we need to take it into account.
Yeah.
No,
so
not in formal way, not in formals.
Yeah, just to mention, sometimes it's definitely depends on your task criticality or risk. They typically based on the, as you mentioned, the probability, severity, and detectability of the potential hazard, right? So you can implement some measure and definitely decrease the severity. So it's a good metrics which could be taken into account. Just comments. And my question is about AI a little bit. AI, it's about like learning from experience. It's like adjusting to the new inputs. Could you elaborate in how did you use AI? Or did you use some kind of software? So could you explain role of AI in your application? How did you use some kind of AI, which we typically shall understand by AI? Did you use some software or AI-based software? What about AI? Could you show me again in your research the role of AI to resolve this problem?
Okay, so in this context, AI we can look for an AI from three perspectives. It's AI for defense from cyber attacks, such as anomaly detector. AI could be object of attack. For example, if we are talking about adversarial or poisoning attack, and AI and it could be AI-powered threats and attacks. And we need to take into account when we create some countermeasurement or some features, need to understand if it's possible to crack your system via AI technology.
Okay, now I understand. So it means you IMECA techniques has just need to take into account the new environment, right, related to the AI. But it's not
yes.
like techniques which is you IMECA is based on. Okay, now I understand. Do we have any other comments, question to Elena? Okay, Elena, thanks for your presentation.